Hello, guys. Welcome back. Welcome back to Chinta Academy. So we'll be discussing today about certain problems. Let me share the screen. Good evening, all of you. By the way. Yep. So hi, Ananda. Hi. So let's start discussing soon. So today will be as usual. We will be discussing problems on like various like mathematical problems, right? That we usually do. So we'll be starting to do that soon. So I hope I'll let the other students be active over here, and we'll wait for some time. Give me a minute. Yeah, so let's start, guys. So let's do the first problem. It's a geometry problem that we're going to do, and let's do this problem. The triangle is about basic geometry, and yep. So this is what the problem is all about. Let's see. I hope all of you can see the screen over here. Yep. So let's focus on the problems. In the diagram, nine isosceles trapezoids are given, which forms a closed ring. Okay, interesting geometry, interesting problem. So essentially, so this trapezoid is trapezoid where each have equal sides. So let me show it with you with corresponding markings. So these are parallel lines. This is what the isosceles trapezium is, and these are equal. All are equal. These things are all equal. And it's required to find out that what is the measure of angle ABC. That is, what is the measure of angle ABC, this one. That is what is required to find out. Okay. Sounds interesting. So how do you actually find this out? Yep. How do you actually find this out? Any hints, guys? What do you think? How we can approach this problem? Any ideas? Five identical, nine identical isosceles trapezoids are there, which forms a closed ring. Then how we can find out the measure of angle ABC? What do you think is a very good opportunity over here? Like any ideas, guys, in your mind? Hello, Saradip. So yeah. So the first one thing coming to my mind randomly is that, can you tell me this? What is the measure of this angle? Let's say, okay, I should give a different color maybe. Let's see, what is the measure of this angle? This angle. What is the measure of this angle? Green angle. I should be using a different, yes. So this angle. So you can find out, right? What is the measure of this angle? How can you find it out? Okay. Okay, so yeah, you have a regular octagon, or are you sure octagon? One side, two side, three, four, five, six, seven, eight, nine. Nonagon. You have regular nonagon. So if you have a regular nonagon, what is the angle? Each of these angles. Let's say this is P. So what is the angle PBC? So how do you find an angle? It's here. It's sum of the angles is, if you just divide this any polygon into any n-sided polygon, okay, into triangles, you will get this sum of the n minus 2 triangles you will get, okay. And if you get n minus 2 triangles, sum of those angles is essentially equal to sum of these angles, okay. So therefore n minus 2 triangles are there, so it's essentially 180 degree into n minus 2 total area by n. So you get each of these angles as, I think, 140 degree. Am I right, guys? What do you think? Yeah, 140 degree. Yes. So n minus 2 triangles are there. Some of the angles is 180 degree minus n minus 2. And each of them is regular or nonagon. So therefore, we are getting each of these angles is equal to 180 degree into n minus 2 by n. You're right. So now what do you get over here? PBC is equal to 140 degree. This angle is 140 degree. Now, how can you find the angles of this isosceles trapezium? How do you find this isosceles trapezium angle? How do you really find this? You did not find this because these two are equal angles, okay? The brown angle and this angle are equal because isosceles trapezium and they're identical, congruent. So therefore, the rest of the angle is what? 220 degree. And therefore this two are equal, so you divide by 2 to get 110 degree. I think Ananta is right. Yeah, Anantaraj, you're right. Yeah, say ABC is 110. Perfect. Okay, let's move on to the next problem, guys. Let's move on to the next problem. It's an easy problem, relatively. Let's move on to the next problem. Any doubts in this problem, guys? I hope there's no doubt in this problem. Okay, this is a generic problem for Olympiad. We'll sort of generalize this problem too. Yeah. So determine all pairs of integers x comma y, x less than equal to y, such that 1 by x plus 1 by y yeah, Ananta, please don't spam the chat, okay? Anyway, so let's do this problem. So number 3 problem. Determine all pairs of integers x comma y where x less than equal to y, for which 1 by x plus 1 by y is equal to 1 by 4. Okay, so how do you approach this problem? Any ideas on approaching this problem, guys? So yeah, it's a very interesting problem. It's a very general problem too. So how do you approach this problem? Okay, multiply both sides by xy. One by x plus 1 by y is equal to 1 by 4. So it's asking us to multiply by xy, so you get x plus y is equal to 4xy. Okay. No, I'm so sorry. It's equal to 4 times x plus y. What's next? Yeah, 4x plus y is equal to xy. And you get, yes, you're right, ratio. Ah, that makes sense. That makes sense. So yeah, so therefore you go that, yep. So you try to do some factorizations over here. 4xy minus 4x minus 4y plus 16 is equal to 16, and you get that x minus 4 times x minus y minus 4 is equal to 16. Lovely. So therefore you get the following, that x minus 4 divides 16, and it implies that y minus 4 divides 16, like is a raised to the divisor. Okay, so what do you get from here? What do you think is a, okay, so how do you do this generalized problem? So essentially the idea is that you find out all the divisors of 16, and since x is less than equal to y, x minus 4 less than equal to y minus 4, so therefore you take till all the divisors for x less than equal to uh 4. Okay, that is 1, 2 and 4. Similarly it will give rise to, like, I think 1, 2 and 4, x less than equal to y, yeah, 1, 2 and 4. Therefore you get corresponding over there 16, 8 and 4. 1 to 4, yeah, 1 to 4, yes, 16, 8 and 4, yes. So this is the x minus 4 you get, and this is the y minus 4 you get. And yeah, from there you can get x and y from here. So 3 solutions are there. Okay, all of you understood this idea? Yeah, so negative solutions are negative solutions used? I don't know, like, but just wait a minute. All pair of integers. Oh, negative solutions are is required. Yep. So thank you so much. So essentially you do plus minus 1 also over here. So then okay. So 1, 2, 4 over here, positive solutions. Yeah, thank you so much. And negative solutions clear, minus 16, minus 8, and minus 4. So 6 solutions, you're right. Okay, so now what we will do is that we will generalize the solution now. Okay, now minus 1, yeah, we will generalize the solution now. Yeah, so we'll generalize the solution now. So in this case, what we will do now, in this problem, what we will do now, we will replace this problem to 1 by any d instead of 1 by 4, any integer. Let's see what can happen over there. So we get 1 by x plus 1 by y is equal to 1 by d. And from there we get d into x plus d into y is equal to xy. And from there we add this to the same thing once over again, x minus y, xy minus d x minus dy plus d square is equal to d square. And therefore we get that x minus d into y minus d is equal to d square. Okay, guys. So essentially, what is the generalized solution? Okay. So essentially, what is the way of approach now? The way of approach is the following. It's now the same, right? So essentially, this is equivalent to the number of such solutions will be equivalent to what? Will be equivalent to the number of divisors of d square, right? So similarly, what we have got that x minus d divides d square. So therefore, number of solutions is equal to number of divisors of d square. Okay, so why? Because if we include negative plus positive solutions. So for all the solutions will be initially, all the positive solutions will be in the form, since x minus d is less than or equal to y minus d, all the positive solutions will be of the form less than or equal to d, and all the negative solutions will be on the other hand side. So essentially, yeah, it's the same. So d square, or I think, yeah, all the positive divisors, number of divisors of d square, positive divisors of d square, negative plus positive solutions. So therefore, what do we get? So now this is a d square. So that is really interesting, and you know how to compute the number of divisors of a number, right? How do you compute the number of divisors of a number? So this is, let me show it to you. Suppose n is a number, and if it's p1 whole to the power alpha 1, p2 whole to the power alpha 2, dot pk whole to the power alpha k. Okay, so what do we get over here is that n square is equal to p to the power 2 alpha 1, p2 to the power 2 alpha 2, dot dot pk to the power 2 alpha k. Okay, so number of divisors will be what? Number of divisors will be, let's see. So now what are the number of divisors? The number of any divisor of the n is of the form p1 to the power beta 1, p2 to the power beta 2, p3 to the power beta 3 dot 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 pk to the power beta k, where beta I is less than equal to alpha I, right? And greater than equal to 0. Each of the beta i's, right? That is beta 1 less than equal to alpha 1 greater than equal to 0, beta 2 less than equal to alpha 2 greater than equal to 0. Okay, I said it will continue like this. So there are k options, right? K places beta 1 beta 2 dot beta k के लिए. First beta 1 के लिए how many options are there? 0 1 2 dot alpha 1, that is 1 plus alpha 1. Second के लिए कितना options? 0 1 2 alpha, that is 1 plus alpha. So therefore similarly we will get its product is 1 plus alpha k. That is how the product is all happening. So this is the number of divisors of n. The number of divisors of n square is what? Is 1 plus twice alpha 1 times 1 plus twice alpha 2, because that's how the power is now. Alright, 1 plus twice alpha k. Okay guys, that's everything. That's it's all about, right? That's it's all about. Now I will generalize the problem to another perspective. So there are two dimensional generalization now. Okay, so why we are discussing this, so that we can understand that, as I always told, never do problems just when you stop there. Okay, try to understand and generalize the problem so that and you can understand what is really happening over there. So essentially, this problem 1 by x plus 1 by y is equal to 1 by 4 is generalized to 1 by x plus 1 by y is equal to 1 by d. Okay. Now the next idea is that it can be generalized into now two directions. Like 1 by x plus 1 by y plus 1 by z is equal to 1 by d, or 1 by x plus 1 by y is equal to, instead of a number integer, we can do a fraction. You see, now this becomes a bit harder. Fraction. So tell me which one you want to solve now. I don't know the solution of either, like I'm just thinking with you. So I will try with you guys. The number of divisors of this not into 2 is not the correct solution though. Okay, second one, fraction. Let's write that. So 1 by x plus 1 by y is equal to p by q. This is interesting. So you get q. Let's see if we can do it in the same approach. Qx plus qy minus of this times pxy is equal to 0. Huh. Okay. Okay. So what can we do with this? Hmm. Let's see what can we do with this. Um, huh. What can we infer about P and Q? Let's try to find it out. The relation is there any relationship between P and Q, because it's essentially a linear factorization problem. You can see that. So we're trying to find integer solutions to this. 1 by x plus 1 by y is equal to P by Q. So we're generalizing it from the aspect of 1 by d to any rational number, P by Q. So we are trying to find in two cases, is there a rational solution, is there an integer solution? So we're trying to find two cases, number of rational solution, number of integer solution. So initially we are doing the integer solution now. What we can do, let's see. Okay, so what's on your mind, guys? Any ideas? There can be one option. As far as I can feel, if we can use that idea that suppose P divides Q square. So then what we can do, we can actually add Pxy minus Qx minus Qy plus Q square similarly, and we can do it in the same way, I guess. Px minus Q, will it be in the same manner, times x minus Q by P, no wait, y minus Q by P. No, it's not happening. Okay, I can add by Q square by P, I think. Yes, this is a good thing. Q square by P, Px minus Q. Yeah, I think this happens actually. Okay, this makes sense. Yeah, this makes a lot of sense. Okay. Yeah, so we get it's equal to Q square by P, and we get that therefore, okay, in this case, we cannot really tell what is a really integer solution, but we can get a rational solution for sure. All if understood this way, we can get a rational solution. Qy minus, okay, Qx, we got it, plus Pxy plus Q square by P. Okay, this makes a lot of sense. Yes. So we get that Px minus Qy divides Q square by P, which is an integer. Which is an integer, and yep, and therefore we get that Px minus Qy is some number, and we can get a rational solution from it. But let's say this doesn't divide, so we also can do it in the same manner. Like we get the same thing, that x minus q by p into y minus q by p is equal to q by p whole square. That is what we get over here, right? Yeah, yeah, exactly. This is correct. We do 1 by q, and yeah, perfect. So this is what we get. And yep, so I think from here we can, so it's like an example, like let's take an example like this, like say 2 by 3 into y minus 2 by 3 is equal to 2 by 3. I mean, this is actually not a good solution, because for anything we can easily get, like we take, yeah, it's not really a good solution. X is equal to, we take 1 by, yeah, it's not really a good solution. So therefore, yeah, this is not a good solution in terms of rational numbers, because rational numbers are not interesting. What we can think is the following, that therefore, yeah, this is what we are getting over here. So therefore, yep, this makes sense. So what we can do from here, when it will be an integer? That's a very big question actually. When x and y can be integers. So it tells that x and y can be integers. Okay, we can do like this also. Px minus q times py minus q, when you're multiplying by q, so is equal to q square. That's what we are getting, right? And what we are getting is here that px minus, is it really happening like this? I think so. Yes, it's happening like this. P times, yeah. So therefore you get px minus q divides q square. Okay. So what we get, that px minus q is equal to d. So p divides q plus some divisor of q square. This makes sense. This makes sense. Yes. This makes a lot of sense. So what we have got is that to have this solution, that 1 by x plus 1 by y is equal to p by q. Okay, we have got that p minus x, to get an integer solution, we have got that p minus x, px minus q divides q square. Okay, so what we have got is that p minus x, px minus q is equal to some d, which is the divisor of q square, and therefore we get that qx px is equal to q plus px is equal to q plus d. Okay, that's good, really. Okay, so yeah, we get px minus q is equal to d, and we get that p divides therefore q plus d for some divisors of q square. This makes sense. Excuse me. Excuse me. Okay, so we have got that p must divide. Okay, so p is such a number such that p divides q plus some divisor of q square. For all this pq, it happens where p, I, q are positive integers. Okay, this is a really interesting set. Okay, yep. So this is a problem solved. Okay, you can do the other generalized problem. Okay, that is a bit harder, of course. That is a bit harder. That is not so easy. Okay, so let's move ahead to the next problem of today. You're right, tangent of a circle. Let's do this last problem for today. This is a harder problem though. Okay, we may not complete this within time, but it's worth trying. It's a game problem. So yeah, so 90 players are there in a league. Each of these 90 players play exactly one match against the other 89 players. Each match ends with a win for one player and a loss for the other player, or with a tie or for both the players. Each player earns up 1 point for a win, and 0 points for a loss, and 0.5 points for a tie. After all the matches have been played, the points earned by each player are added up, where the greatest number of players whose total score can be at least 54. Ah, this is interesting. Where the greatest possible number of players whose score can be at least. Okay. 4 by 3 is the correct solution. Yeah, you're right. 4 by 3 is the correct solution. In fact, you can do it for 2q by 2. Sorry, q by 2p is the solution for each one of them. Okay. The thing is that we are not liking that because it's generic for all. So we are liking some special stuff, and special stuff comes up in that corresponding argument. But you're right, totally. You're actually correct. Okay, so let's try this problem out, guys. Let's try out this problem now. So 90 players in a league, each of the 50 players. So what does the problem ask you to find? The problem asks you to find that the greatest possible number of players whose total possible score can be at least 54 points. Okay, tell me one thing. What are the sum of the scores of each of the players? The sum of scores of all the players. Can you tell me the sum of scores of all the players? It question means that we need to find the total number of players whose score can be at least more than 54. So therefore, we need to find out how the score is distributed among the persons. Like total number of matches. Guys, what is the total number of matches? Ananta, 90 players are there. Read the condition. What can the total number of matches played? Think about it. Ninety players in a league. Each of them it's played exactly one match against the other. 89 players. So what is the total number of matches played? Tell me, it's easy, guys. Not 90. Suppose there are 4 players, Ananta, and each player plays along with the others. It's like n choose 2. We are taking 2 players and taking How many such possibilities pairs are there? So 10 choose 2. So 90 choose 2. Okay, 90 choose 2. It is 89 into 90 by 2. Yeah, exactly. Exactly. So you get it's equal to 4005. Total number of corresponding uh like games is 4005. It's asking how many possible players are there whose total can be at least 54. Let's say the average number of players. So 4005 by 54. If we divide the score uniformly, okay. If we divide the score uniformly, then let's see what is the possibility over here. If we divide the score uniformly, we get that it's around 74.17, which is not an integer. Okay, so we need to make some changes over here. So if we try to divide the score equally among all the people, we get that. So also understand this, that suppose we are trying to find n. So n people have got at least 54 points, right? And you can have in the other people have got 0, okay? So what is the idea? 54 times n must be less than or equal to 4005, total number of points. Because each game ke liye, either you get 1-0 if it wins or loss. If in case of tie, you get 0.5, 0.5. So essentially each game ke liye 1 point. So therefore number of points, number of scores, sum of all the scores is 4005, and 54 into 9 is less than or equal to 4005. So also therefore you get n is less than or equal to 4005 by 54, which is equivalent to 74.17. This is what we get. Yeah, you're right. So the question arises, what is the maximum possible value? It seems like n is equal to 74, but it can, for n equal to 74, some contradictions can arise. Okay, so what are the contradictions that can arise? These are the questions we are asking. Okay, the idea is this: each game leads to 1 point. The sum of like 1 point, sum of the scores of of all the people is equal to all the players is equal to number of games, because each game leads to 1 point. Let's say n number of players got at least 54 points. That's what the question is asking for, right? And therefore we get what? We get that the sum of all the, it can happen that n people got 54 points and the rest of the people got, the 36 people got 0 points. So 54n can be the, so therefore 54n is less than equal to sum of all the scores of all the people, because each people have got 54 points. So 54n is the total number of sum of the scores of those 54 people, of those n people who got at least 54. Yeah, that's the idea. For die, the one score is divided into two equal halves, 0.5, 0.5. The sum is same, see? The sum is 1 here, the sum is 1 here. Did you get this idea? So therefore we got that n is less than equal to 74. So and we get that 74, n is less than equal to 74, and we get the following result. We get the following result, that n is less than equal to 74. So yeah, so just wait a minute, this sort of hanged. Give me a minute, guys. So Neha, you can do your corresponding. There's a good book called. You can start with pre-college, Neha, and pre-college you can do the basic combinatorics, and then you can move ahead to excursion in mathematics. If you go to the website, you will find the books. Okay, pre-college is a very good book to start with. You can do the basics. It's very basic. You will love it. So this is what we have got. N is less than equal to 74. So therefore we got this idea. Let's see what idea do we get. We know that 54 into 7, like 74 people, if n is less than equal to 74, 54 is the point, right? At least. So therefore we get that's, this is 3996, and 75 it cannot happen, or maybe it can be equally distributed. So suppose 74 people have at least, so let's retake the cases. Suppose 74 people have at least 54 points. Okay, suppose 74 people have at least 54 points. So what we get? So we get that 3996 is the number of points over here, and we need extra 9 points. Okay. So what do we get over here? Think about this very carefully. We get that 74 people have at least 54 points, and we have, just understand this very carefully. People have at least 54 points. We have 90 players, so 16 people must have the rest of the 9 points. The 16 people must have the rest of the 9 points. Okay. So how can we do it? The 16 people play exactly how many games among each other? 16 into 15 by 2, 16 choose 2 games. That is 120 games. Okay. And if they obtain more points while playing with the and essentially have at least 150 like this is the idea, okay? 16 players are at least 120 points between them. That's the idea. And possibly more if they opt in playing with the other 54 players. So how do we approach this then? So therefore, what is the idea? Therefore, the 16 players can have at most 9 points, but it needs at least 120 points in total, right? This is the idea. So they need at least 9 points to complete because it's 3996 and 996, and therefore they need at least 9 points. You understand? 16 people have at least 9 points, and among them they play at least 120 games, like at, exactly 120 games among them, among 16 persons is the left. But 9 points have to be distributed with the 16 points because they have lost with the other people. Suppose they have lost, so it's never possible. Okay, that's the idea. So similarly, you can do the other cases too. Suppose they have there are 73 people who have. Did all of you understood the arguments over here, guys? The rest of the problem approach is similar. We do it for 73, we do it for 72, and we continue doing this. Yeah, sure, awesome. Anyone can crack InMo without any mentor, yes. But he or she has to work hard. That's the idea. But sure, anyone can do it, everything with himself or herself, of course. So how do we do this? For 73 people, we have 3942. This is 63 points, which is distributed among 17 players. You can still check it cannot happen. So you can check for 72 also, it cannot happen. But you will check for 71, it can happen. 71 is the perfect player. Okay, let's check for 71. We'll do it for 71 once. Let's say 71 players. For 71 players, you get the 71 players have got at least 54 points. Let's say 54, and which is 3834. So you have got 19 people over here. So the rest is 66 is left plus 120. That is 186 is left points. 186 points left. Am I correct? Am I correct? I'm so sorry. 186 nahi. I'm so sorry. What I am doing? 66 over here. This is 190 plus. So 171 points left. 71. 171 points left. 171 points left. 19 players are left. So they will teach. Sorry, they will take. They will play by this two number of games, which is equal to again 171. Lovely. Yeah. So therefore, in this case, they exactly get the same number of points left and the same number of points they have won. They are left. So what will be there? So it will that in fact this is what happened. The 71 players जो जिसके 54 के ऊपर है, 19 players जिसके ऊपर है, for each one of them it ended in a tie. For each one of them, it ended in a tie, and here they won alone. Let's check. Suppose this happens. So 71 into 70. For each person, 70 games they have played into 0.5. There's 35 plus 19 for a win over there. So you get 54 over here. And here they get 19. They have a tie, so 18 into 0.5, that is 9 each points. That's it. That's all idea. So it's all 54 and then last of them 9s. This makes sense. 19 of them 9s. So therefore, this is the idea. This they won. They had a tie between them. They had a tie between them, and they won over here. This 54 greater than equal to 54 persons. Also understood this, guys? This is the basic idea behind the problem. This is the entirely basic idea behind the problem. Okay, so okay, so perfect. So let's end the class over here. I see you in the next session. Bye bye.